Leetcode 141 linked list cycle. It's an easy problem, and basically what it does, it tests your understanding of linked lists. If you, as it's hinted in the title, and if you have a good linked list model, mental model in your head, if you can imagine what it is, how it operates, then you should probably have no issue solving that problem and other related. And basically what it is, it's a collection of nodes. List itself consists of one or multiple nodes which are somehow connected. And how are they connected? Well, they store value, which is data, could be some integer. Usually here on Leetcode there are just integers, but in real life it could store anything. And the second important thing is, of course, this next, which is a reference to another node. That's how list operates. Each node knows which one is the next. And things can be simple in a way that one node references just another node in the list and there is no going back. But there could be, of course, a thing that we will be looking for in this problem, and this thing is called cycle. When we go up to a certain node and this node references back some other node that was already in our list, creating a cycle. And it can exist in any place. For example, you can have last node which references back the very first node, or even one node somewhere in the middle referencing itself. So it can exist in any place, and we will be trying to track it down throughout this video. And here is the description. Given head, head is usually the first node, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in linked list if there is some node in the list that can be reached again by continuously following the next point. So this is more like a concrete description of what I was already trying to explain in my own words. Internally, pos, that's the position, is used to denote the index of the node that's tails next pointer is connected to. Note that pos is not passed as parameter. Return true if there is a cycle in the linked list. So here is the output. It's a boolean, either true or false, otherwise return false. And here is an example. And in this example, they are passing an array and passing the position. But inside our code, there is no such thing. We will be operating on objects of that class, list node, and we simply get an instance of the list node and nothing else, which we will have to unpack the list by going through those next references. But here there's a little bit different situation, but we can still learn a lot, I think, from those examples. So here is simply those values in that array correspond to values stored by each node. So for example, first value in the array is 3, and that's also the first value which is stored by the first node, and 3, 2, 0, -4, and so on. And on position 1, and they say that there is a cycle. And there is a cycle in the linked list where the tail connects to the first node, and it's 0 index. Okay, and here is another example which is kind of similar, so we don't really learn anything from it other than the list is a bit shorter. We also reference back, as here, but inside the input, for example, here there is no information about the references, what they have specified here. We can just learn from the pictures. And the third, they just drew single circle, and of course, if there are no arrows at all, no connections, then false, there is no cycle. So let's maybe try to work from that and think about some algorithms that we can use. And there's also one more information here, follow up. Can you solve it using O1, meaning constant memory? So we will try to use at least 2 different approaches, and one will use O1 memory. But let's not get ahead, just the small preview of what is coming. And now we will draw our linked list, and let's make it smaller first, like this. And now we can make it bigger. No, I thought that it will also grow bigger, but no. So we can make it bigger like this. And 2, 0, and here is 0, -4. And of course our arrows, connections between them. Well, this one goes to this one goes to this one goes to this. And here we have to draw an arrow like this. Yeah. So how can we detect cycle? First of all, we need to know how can we even iterate through our list. Let's copy that, just so that we don't forget. How does it work? And let's put it here like this. And here is our class, but I want to somehow mark all of those and nothing else, just to give a little bit more space to make it more readable. And we will have objects of this class inside our code. Yeah, first one will be this, and it will store value, which is equal to 3, and it will store a reference next to the next one, which is 2 in that case. Yeah, so how can we iterate through list having only those objects? We first need to go to the next one, and from the next one, which will also be an object of that class, we can get also reference to the next simply by going to the next. Yeah, and this will continue up until either the list terminates, because the last element in the list will have reference to next set to none, meaning that there is nothing next, or until we will see again a node that we've already seen. Yeah, so what we can do is simply iterate through the list by going to self next every time, yeah, until you see a node which was already visited meaning cycle, or until there are no more nodes, meaning self next is equal to none. Yeah, so there are those two options, and in that case we return true, in that case we return false. And now, how can we do this? We can either, one option is keep track of all the nodes which were visited. Yeah, so create additional structure for that. For example, a set. And as we iterate through the list, let's make it a bit smaller, we could simply, for example, add every single node that we've already seen to some set, and then always check when we go to the next one, is it already in the set? If so, then we have a cycle. Or another option would be have 2 pointers for iteration. Yeah, one fast and one slow. How will it work? The fast one will go 2 steps each time, and the slow one will go 1 step. And if the fast one at any point equals to the slow one, then it means that there is a cycle. Yeah. So, for example, the slow one, let's make them like this, or maybe let's use arrows for that. Which one is slow? Slow would be green, and fast is red. Red is much faster than the slow, and both of them start. Oh God! Both of them start here, but in each iteration, this one goes 2 steps. So first it will go here, and this one will go here. And in the next iteration, this one will go here, and will reach that point. So the fast one will move here, but the slow one will also move. So at this point, we will not yet see if it's a cycle, but what will happen in the next iteration, this will go here, and this will go here, and that means that we have a cycle, because they met at some point in a node, which is not necessarily the node that is where we go through where the cycle starts, but it will happen at some point for sure if we go using both slow and fast. So it doesn't mean that we will detect it as fast as possible, but we will detect it without any additional memory. But if we keep track of all the nodes, then we will track it down faster, but we also will use more memory. So let's try using both approaches. And which one can we start with? Maybe let's start with the first one first. Visited, so we will use set and keep track. So option 1, keep track of nodes we've seen so far. And while node first is equal to the head, yes, and while node next not equal to none, we move it by 1, so node equal node next, and we check if node is already in visited, not is in visited, then return true, otherwise return false, and else add it to the visited, or we can simply use it without else, because here we already return visited add node. And let's try the first option. And everything works perfect, so no spelling errors. But here, we can have, at this point, when we add it here, it can already be. So we can simply change this because at this point it can already return none if it doesn't have any next node. Then we can simply check it by this, by removing this condition, and then it will keep iterating until node itself is none. And let's resubmit. And we beat about 50%, but we use too much memory. So there is the second option now. Option 2, use slow and fast pointers. So this part we comment out. We can just reuse this, because of course if we reach the end, then we haven't detected any cycle. And now let's create both slow and fast, which will equal to the head at the beginning, and while fast both while slow and fast. We can just check. And then if slow equals to fast, return true. And slow moves by 1 and fast moves by 2 steps. And here I think we need another guard. If fast, then fast equal fast next, because this can already return now. So let's check. That's correct or not. In the case, how to put it true? If slow equals fast. Yeah, because it's an empty, not an empty. We have just a single element. Let's think about it for a second. Make it a bit bigger. So fast. Looks like this loop condition is too weak. So instead of doing this here and this here, we can simply check for both here. And in this case, we will skip this single element lists already here at this point and return false. So let's try. And let's see. That worked. Now we are both faster and use less memory, which is great.